So hello everyone, I'm Tao. You can also call me Ethan. So welcome to my workshop about smart contract security, especially for the Cosmos Watson. So today, our smart contract will not be coding along, since we're going to cover uh, a basic introduction about Cosmos Watson smart contract security, and also the basic introduction about the testing techniques in the smart contract. In general, we're going to discuss some common knowledge, and we will not code anything in this workshop. So only ability to read some code is enough for this workshop, and uh, the, the workshop will is going to be about 40 minutes or 15 minutes workshop. So you can grab a coffee and take some notes if you want to. And hope you enjoy this workshop. And okay, I can. So let's go. Let's start it now. So first, I will do a quick introduction about myself. So I'm working as a security researcher in Beosin, which is focused on smart contract uh, research and auditing. And also, I'm also doing the on-chain analysis in the Ethereum and other EVM compatible chains. And uh, so, so to give you a brief background about the blockchain and also smart contract, the blockchain is a type of uh, distributed computing system, and also the blockchain technology is quite popular right now. And there are many types of blockchains. So we have Ethereum, Solana, and Cosmos ecosystems, including the Nibiru blockchains. So, um, and there's the smart contract. So smart contract is a bundle of code and data that runs on the blockchains. And smart contract always deal with the cryptocurrencies, and usually we can see uh, a contract will take uh, will deal with different uh, virtual assets, and the var- and the various transactions will be made in the uh, in the in the contract execution and interaction with other smart contracts. And smart contracts are built based on the Cosmos Watson are generally created using the Rust language. So Cosmos Watson is a smart contract platform, and it's a module in the Cosmos SDK. So in other words, if a blockchain is built based on the Cosmos SDK, or a, or a blockchain is using Cosmos SDK, so the blockchain can easily support the Cosmos Watson smart contract. And Cosmos Watson runs within the WebAssembly virtual machine. That is, Cosmos Watson smart contract will be compiled and converted into WebAssembly bytecode uh, in the compilation. Yeah, so that's a general overview about the Cosmos Watson, and we will see the common issues in the Cosmos Watson smart contract later in the following slides. And since the blockchain technology is popular and also deals with cryptocurrencies, so blockchains and also smart contracts have become a hot target of many hackers, especially especially for especially because the smart contract deals with the cryptocurrencies or digital cash. So if there is a bug in a smart contract or on a blockchain protocol, it could lead to a great loss in the crypto assets. And, Cosmos ecosystem got hacked several times before, and a great amount of money was hacked. So here is the example of the Juno action. So there is a loss. There was a loss of $36 million loss simply because the Juno tokens were transferred into a wrong malicious address. So, and what is surprising is that so these hackings are only a tip of iceberg in the Web3 security. So we can tell how important that the security in the smart contract and in the blockchain would be. So before we get started, so we need to know that and understand that Cosmos wasn't safer than Solidity. So although Cosmos wasn't may have some security issues and also security incidents that has happened before, but Cosmos wasn't is safer than Solidity because Cosmos wasn't has prevented the reentrancy attack when it was designed, and also since Cosmos wasn't is implemented based on the Rust, so Cosmos wasn't provides developers with more precise and stronger guarantees in the memory safety and also concurrency. So that's one thing that I need to tell you. So Cosmos wasn't is safer than Solidity, and that's why many developers try to work from the Solidity to the Cosmos development. And due to the time constraint, so I will not give you a list of all the big types of Cosmos smart contract security issues. So what I can do is to give you the most common important types of the vulnerabilities in the Cosmos contract. So first, using a vulnerable module is dangerous not only in the Cosmos smart contract but in all the programs. So this is an example. I don't know if you can see my mouse. This is an example that a vulnerability that was found in the Cosmos. So many developers always use lower cap for addresses, and address validation function will recognize correctly if the addresses is just lower cap. However, the address validation function cannot recognize the address if an address is just uppercase. So there are many problems that become issues, and the update will be made later. So we need to follow up these issues and to update the modules promptly. And the second one is about the address bypass. So a smart contract might to implement whitelist and also the blacklist or blocklist to restrain the access to restrain the address to access some codes and to call some functions. So if there is a problem in the address check, so a smart contract can allow unwanted address to access as some important or critical code. And so for example, an attackers may bypass the address validation and to drain all the funds in a smart contract. And we will see an example later. So here's just give you an impression. So we'll see a bit codes later. So for example, we just talked about the vulnerability modules. So about the uppercase address and also the lowercase address. And if a blacklist that contains all the addresses that are lowercase, so a hacker can just use an uppercase address to bypass the blacklist. And yeah, that's the easiest one to just to drain the funds in a constant wording smart contract. Yeah, and so the address bypasses is a critical thing you need to check during the constant wording smart contract development. And so another big issues is about the integer related bugs. We will talk about the overflow, underflow, and also the rounding issues in this part. So when we develop in the Ethereum smart contract, so when the integer overflow or underflow, so the value will overflow, will be overflowed or underflowed without error. So developers may not realize that the overflow or underflow issues. But in the constant wording smart contract, so when you do the compilation, so your program will stop when there is an integer overflow or underflow issues, and there may be a panic functions to remind you to check where is the overflow and underflow address. And also pay attention to the type conversion error, especially when you do some less calculation. So in this example, we can see, so we add two uninteger 256 variables, and we only use the C variable, which is an integer 1 to 8 types, or that will be an type conversion error and might cause serious problems during the following calculation. So please be aware about these kind of common issues. And for the rounding issues, so rounding and the truncation, so are the most commonly mask-based security issues in the constant wording smart contract. And so the rounding issues always start with a division, but it can has different outcomes depending on the business logic and the scenarios. So the reason that the rounding issue and the truncation issues exist always may have these three scenarios. So first one is to do ratio calculations using integers. So that's the most common one that the rounding issue or truncation issues exist. And also, so you so the second one is when the smart contract execute. So the rounding issues happen against the protocol. So that is the contract loses a tiny amount of some crypto assets per operation, and that would be cause a validation error or cause a liquidation error. So especially when your projects are lending protocols or lending protocols or some projects like lending protocols. And the third one is operating assets with different numbers of decimals and without prior normalization. So just like our example before. So when we do the calculation, we only use an integer 1 to 8, a variable to contain the result of two an integer 258 variables addition. So that's the three common scenarios causing the rounding issue and also the truncation. So to avoid or to mitigate the loss of the rounding issues, so first you should do multiplication before you do the division, and make sure to make use of scalar factors to increase the resulting precision. So you can do like 100 times or even 10,000 times when you do the division, and then you can get a more precise result. So that's the second method. And also, if the rounding issues are inevitable, so you should round in favor of the protocol, so instead of the user. So that's the one thing you need to choose to do. Since if you do the rounding in favor of the protocol, you can avoid problems like liquidation error and also many potential errors that may cause the gem of the protocol treasury. So you can save your protocol when you do the rounding in favor of the protocol. So yeah, please keep this in your mind. So if rounding issue is inevitable, so please do the rounding in favor of your protocol. And the last one, we will see a concrete example, and you can pause the video and read the code to see what kind of issues it may contain. And so I make it about 5 minutes, so you can pause the video, and then I will talk about the security issues in this node. Okay, so it's a function in a conservation smart contract, and so we can see from its function name that. So it's an update configure function. So it's to update the configuration of a smart contract. If you look at if you look at the update configure function, so you can see there's no security issues at the first glance, since so it send the rewards. So it send the rewards to the word address, right? And so you can change the address or receives the rewards in word, right? Right. So you can see that this is the access control issues. So we didn't so the smart contract didn't restrict the address that can update configure. Well, so we need to anyone can update the configure and to set the messenger port address to his or her own address, and to move the funds from the rewards word to the to his or her own address. So that's the issues about the functions. So we need to think about the access control in every functions, especially especially for those critical functions that deal with the rewards distribution or airdrop, or some functions that control the smart contract. So that's the issue in this Cosm Watson smart contract. And please make sure you need to check the access control of all the functions, especially for those important functions in the contract. And after talking about the common issues in the Cosm Watson smart contract, I will talk about the common testing techniques in the smart contract audit and also in the smart contract development. So here is the overview of the process of the smart contract development and auditing. So first one, we need to do the code development. I want to add some comments in here. So before you do your code development, so you need to design a rigorous business logic in your protocol. So that's the prior things before you do the code development. So a rigorous and secure business logic in your protocol is paramount for your project security. So after you have designed a secure protocol, business logic in your protocol, then you can do the code development. So during your code development, you will do the testing. So you might do the integration testing and also function testing in your development, and then you might get a static testing, or you will ask security companies or security auditors to do the security test, static testings for you. And the last three part is and the fuzzy testing and the formal verification will be conducted by the security companies after the audit, and uh, you can modify the codes to solve those bugs, and then you can do the development or deployment on the mainnet of a blockchain. And we will talk about the fuzz fuzzing or fuzz testing and vulnerabilization in the following slides, and help you can get a basic understanding about the auditing techniques. And you can also develop your own fuzzer in the smart in your code development. And since you are the one that understand your business logic best, so you can develop your own fuzzer and also formal verification tool to secure your quantum water smart contract. So you can use the security audit and also security detection tools to fill the gap between the developers and also the auditors. So for the static analysis, so it's simple and fast, and many developer teams also use static analysis to scan their codes and find bugs. It's simple and fast, but it's also easy to have false positives. So after you do the static analysis, you need to check the errors reported by the static analysis tools, and then to fix and to identify whether it is the real bug. And dynamic analysis, so many developers will use dynamic analysis since many developers use the test-driven development. So it's kind of like the dynamic analysis. So it's simple with higher accuracy, but it's also easy to have false positives. So the reason dynamic analysis has higher accuracy is that so developers can create the specified test cases for the codes that to be tested. So it's more accurate than the static analysis that just analyze the code and analyze the code without running the code. So the third part is about the formal verification. So it's a technology that proves the functions are correct, so mathematically, and but it's very difficult and costly to use formal verification into smart contract audit. We will see why in the following example. So for the formal verification technology, so first we need to use the formal specification. So we will analyze the code and understand what the code should be, and it's not how to do. So we need to express code functionality or the security attributes in a mathematical way. We will do an example later so you can understand what I'm talking about. So let's look at this simple example. So it's a transfer function, and let's see if the transfer function has has security issues or not. So here's the symbol. So the column equal is refers to assign, and equal sign refers to equal. So we can read this code. First, if we want to transfer some crypto assets to other address or to yourself, let's see. So first, we need to check whether the balance of the sender, whether the balance of the sender is greater or equal to the amount that the sender want to send. And then we need to remove the amount of token in the balance of the sender. And then we add the amount of the token to the receiver. And we update the sender and the receiver's balance. So do you identify the security issues in this transfer function? So we can do. So here is a single test. So it's like a dynamic analysis or just function testing we just mentioned before. So we can do so if the sender is Alice and the receiver is Bob, and we just want to send 10 tokens from Alice to Bob. So we can see the result is correct, but if the sender is Alice and the receiver is also Alice, right? So we will have an error here, right? So the update of the balance of the sender and the receivers has some security issues, and we need to modify these transfer functions. So if we do the fuzzy or fuzz testing, so we can see, so if the sender and the receiver are the same people, are the same person, so we will see there's an error in the balance of the person, right? So we will see that if we transfer tokens to myself, I can hold more tokens after the transfer function, after the transfer operation. So that's the issue. So if we do the quantity analysis, so we can see the invariance. So that's the term. We can see the invariance during the transfer operation. So that is the new balance of the sender and the receiver will equal to the previous balance of the total of the addition of the balance of the sender and the receiver. So that's the invariance, and we need to if our code satisfies with the invariance, then our code will be bug-free. So after we do the quantitative analysis, we can see we can write the formal specification here. So for any sender and any receiver, and to send arbitrary amount of tokens. So the new balance of the editions of the sender and the receiver will equal to the previous balance of the edition of the sender and the receiver. So that's the case that we can remove the bugs in the code. So I think you can have a basic understanding about the formal verification. So we need to do the quantitative analysis. So we need to find the invariance in the function and to write the formal specification for this function. So then we can implement new code based on the formal specification, and also we can use the formal specification to check whether the previous code has some security issues. And so that's the formal verification technology. And here's the fuzz testing or fuzzing. So fuzzing is a method, is a testing method that repeatedly executes the target program with random inputs. So it's simple but effective in the code testing to find vulnerabilities, especially in the complicated programs. So fuzzing has been employed by many software companies and also security companies. So here's the relationship between the fuzzing and also formal verification. So first, here's the constraints of the formal verification. As we just mentioned, we need to analyze the code or analyze the business logic and to write the formal specification. So for many codes, so it's nonlinear computation, and it's hard to write the correct formal specification. So and for complicated programs, so when we analyze the execution path, so there may be many execution paths on the state path and the state path. So we might need the state path explosion. So which means that we are it's almost impossible for us to use formal verification to analyze the code and to find the bugs. So that's the performance issue about the formal verification. And in theory, that formal verification, the bugs found by the formal verification contains that found in the fuzzing. But in practice, I think we cannot strictly prove strictly write the formal verification, formal specification. So in practice, that the bugs found by fuzzing and the bugs found by formal verification, it has an intersection and it has its own outcomes. And that's why when we do auditing, so we always use the the combination of fuzzing and also formal verification. And here is an overview of the vulnerability detection technology. So if there is all the vulnerabilities exist in the code, so the static testing will find a part of the vulnerabilities, and it may have some false positives results. And the formal verification and the fuzzy testing, so it will find security issues, especially for those involved in the business logic issues in the smart contract. So formal verification and fuzz testing will be used to find the difficult to find the issues that is difficult to find. And besides the formal verification and the fuzzy testing, and also the static analysis, so we will do the manual security audit. So since the business logic in different protocols has its own unique execution path and also unique vulnerabilities, so we need to do the manual security audit as specified for different protocols, and as you can see, so even we use various testing methods and also manual auditing, we cannot guarantee to find all the bugs in a smart contract and to claim that a smart contract is bug-free. So there's still a long way to go, and if you want to keep your smart contract secure and find many bugs as many as possible. And that's the overview of the Beosin. So our is a security company, and that's the end of our workshop. And hope you can get an overview of the cross-border smart contract security, and to get a basic understanding of the testing methods. And and hope you can do the secure smart contract development and the projects in this hackathon. Yeah, thanks.